Hello, everyone. This is Antonio Labragetta, and I want to share with you the themes and concepts for Module 3, which focuses on the perception of objects. So let us begin. Um, these are some of the themes they're in your book essentially, but I thought I'd just point them out so that you can pay extra attention to them. Um, your author goes through different aspects, different theories of perception of objects. And one of the, in a more, since, artificial intelligence is becoming more and more ubiquitous, it's studied a lot, in terms of where, computer scientists are making more and more progress in this area. What Goldstein wisely does is, relate the material in this course to computer science. And one thing, as we learn more about how our sensory perceptual system works, this information can be utilized by computer scientists to create computers that can make decisions. And of course, obviously, we need, and things like having some sort of sensory system or perceptual system that works maybe in certain ways like ours, or at least in a way that can maybe copy certain ways that we do things. And that's, one of the challenges of creating computer vision is that we have a lot of top-down processes that have, a lot of that have adapted over the, generations, so that our sensory perceptual system is essentially well suited for the environments that we live in. And that's one of the challenges of creating a computer that can see um, as effectively as a human, which so far it hasn't. I mean, you look in the module, I do have there is some information at TED where computer scientists discuss things, and they're discussing breakthroughs in object perception, but you know, there's still a challenge to do it as well as a human. And so that's one of the themes of the chapter. Also, we're going to be going through perceptual organization because, once again, the whole, perception is that process of organizing the senses into something meaningful. And we'll also be talking about the laws of perception. In this case, talking more about Gestaltian laws and principles. Regularities are also quite important. This is sort of the learning aspect. Our sensory perceptual system learns essentially, by the repeated exposure to certain types of stimuli, and your author does go into that. And this relates, of course, to top-down processes. What is it? What about our cognitions and some of the learned effects? How do they influence our perception of objects? And your chapter addresses them, so make sure you pay attention to that. And finally, one of the recurring themes that throughout this course, in particular with the visual perception, is the importance of faces. There are just so many parts of the brain that work in a coordinated fashion so that we can properly not only recognize a face, but recognize subtle aspects of that face, emotional responses and whatnot. And face perception appears to be quite important for humans. Okay, so let's move on. So here you can see, why is it so hard to design a machine that has accurate perceptions, accurate, in this case, visual perceptions? Well, one of the points your author makes is the stimulus on the receptors is ambiguous. It's not clear. I like to say to my students, it's our visual system, it begins at the retina, really. The light's focus, there's an image on the retina that's shown here. So there's an image here. But this image alone is not, that cannot be the sole basis of all the perceptions that we experience. That's the starting point, essentially. And one of the interesting problems here is that objects on, this is called the inverse projection problem. An image on the retina can be caused by literally an infinite number of possible objects in the universe. All right, and that's what's shown here. Here's someone, let's say you're looking at a piece of paper. But if given the physics of the optics here, essentially any number of shapes could produce the identical image. Yet we have no problem, despite the similarities in the retinal image for these different objects, we can still accurately perceive that it's a sheet of paper, letter size, or it's a different trapezoid or whatnot. We can do this because we have, arguably top-down processes. So, it starts off with that retinal image there on the retina, which is then, this information is analyzed by the brain. But that's just a starting point. At least that's because there's many areas involved. Now, this picture that's in your book is a good example of that. We cannot go solely by the retinal image. When we when all we have, or at least maybe our experiences don't help us, or we're in an environment where all we can use essentially is that retinal image, it can cause error. So here you can see this image here. You've got what looks to be this interesting sort of circle of rocks, and if this was a 3D image, it would be easier to see that this is not the case. And you can see B. Look at that; they're clearly separated, but it's hard to see that from the vantage point at A. And this is a case where the retinal image is tricking us. All right. And, this is a recurring theme in the visual system. The retinal image is definitely important. You have to have it. But then that's not the end of the story. That's really the point here. Um, Objects can be hidden or blurred. Once again, just to make that point again, the stimulus on the receptors is ambiguous. Okay. Objects can be hidden or blurred. There are all kinds of occlusions in the environment, one thing blocking another. I mean, just looking at if you look at your test book and you put a cell phone on top of that, it's two different objects. But how do we distinguish from that? It could just be one sort of weird, complicated object. So it's an ambiguous signal, yet through our experiences we can solve it rather easily. And your author mentions this, shows this here. A cluttered desk. How it's very simple for your typical human to kind of go look at this and be able to discriminate all these objects, their orientations, what they are, knowing that, for example, this magazine or whatever, it looks like it's resting on top of a planner. A computer robot trying to do this, tough, very tough. Right now, robotic vision, if you have pretty clearly distinct objects, the AI can resolve it. But when you start getting really complicated like this, it becomes increasingly hard for it. Objects also look different from different viewpoints. We call this viewpoint invariance, though, the ability to recognize an object regardless of the viewpoint. And this is something it's very difficult for computers to do this. It's possible, but it's difficult. And yet I can look at this, you can look at this image, and you can tell it's the same chair. It's most likely the same chair, but simply in a different position. Please note, though, that for A, B, and C, each of these are three distinct retinal images. So we know it's the same thing, but how does our visual system solve this? There has to be some sort of top-down process going on here. Otherwise, every time we move something, we think it was a different object, which would be confusing. Okay. Make sure you study the, I'm not showing it here so much, but, in the perceptual organization, I want you to focus on knowing the contribution of Wundt, and that's structuralism, and also the Gestaltian psychologists, which got into more of a holistic approach of perception. Wundt, though, he's one of the great psychologists. He created the first psychological laboratory in Germany. He was part of a school at the time, and you can see the time period here, late 1800s, that believed that sensations sort of added up to form a perception. So you can imagine like a face is literally the sum total of all the individual features, the nose, the eyes, whatnot, simply added up, which is a good start. And there's no doubt that complex objects are made of simpler things. But we'll see that doesn't explain everything. Gestaltian said, well, maybe it's not quite that. The whole is different from the sum of its parts. All right, so there's different schools of thought on this. And here you can see, of course, this is interesting. Here's a complex scene again. It looks like a ballpark. And you can see the city in the background. And our visual system has a job here of distinguishing all of these different parts. I mean, once again, this could be one big object fused together, all these parts fused together. But we know from our experiences that, well, we can look at this and see distinct buildings, and then within each building we can see distinctions. That's called segregation. But we also tend to group things, right? Okay? We tend to group things by color, by shape, by proximity, all right? So one of the tasks that our visual system has is to essentially be a contrast detector, knowing where this building ends and this one begins, for example. Contrasts are quite important. Our visual system is really tuned to those type of things. Here's the Gestaltian approach. Now you do have in your module some activities here in which you go into more detail, so make sure you do all that. But here's the structuralists they distinguish between sensations and perceptions. Perceptions were essentially the result of it literally summing up with the sensation. Problem with that, excuse me, is that it can't account for everything. Apparent movement is one thing, and illusory contours are another. And this, I will show you an example of that in a moment here, or in a second here. This sort of summarizes the the structuralist approach, that literally this face of a woman is the sum total of all these little dots, these black dots that are just put about. So literally the idea from this point of view is that our perception is literally the addition of all of these individual sensations. However, sometimes that's not the case. Here you can see apparent movement, and this is once again from your book. Think of let's say a marquee that that flashes or whatnot, where it looks like something is moving, but it really isn't. That's called apparent movement. One light flashes, followed by a short period of darkness, usually on the order of milliseconds, followed by another light flashing in a different position. So we have essentially two still images. They're separated by a slight location and a brief delay. And the perception is essentially almost like a smooth movement from the left to the right. That is apparent movement, because nothing is actually moving there. But the way our visual system is, the way our top-down processes work in such a way as to essentially look at an illusory movement, right? So it's not real, but because our mind works in such and such a way, we experience that. Once again, just any kind of marquee, and you'll see that. Illusory contours. You can see here, even, this is very interesting. You got these little Pac-Man kind of stimuli, like B is really noticeable. There's no doubt that you probably, especially in B, the triangle appears to be popping out. It almost looks like it's in front of the Pac-Man. But there is no triangle in it from a certain point of view. It's all that you've done is create these three little Pac-Men, and yet it almost looks like there's a white line, a contour joining these two, and then there isn't. I mean, there isn't from a stimulus perspective. I mean, there is in the sense that you're experiencing that. So from a subjective perspective, I guess you could say there is a triangle. So, and you can just see these are all just illusory. And this notion of the illusory contour is consistent with the Gestaltian approach. The sum is, the whole here is greater than the mere sum of its parts. We are adding two things. We're adding richness to it with our mechanisms of perception. Once again, I've said this, go ahead and make sure that you go through all of these different laws and all these principles, I should say, and just know those for the exam. They're pretty straightforward. Here you can see, this is kind of interesting. This is another thing that's hard for the structuralist to explain. I mean, literally, with this type of thing, if you know, looking at this picture, what to look for, all of a sudden order is imposed. So these are just, it could appear to be just sort of these random black and white shapes. But once I tell you that there is a Dalmatian in the image, top-down processes, Gestaltian principles start to come at play, grouping and whatnot, then wow, I could actually start to see a dog. This even gets more effective if this were to move. So motion, the perception of motion, you actually can get the form of this. If this thing were to move, it would be an immediate giveaway that there's something there. So this is evidence that it's not just the structuralism cannot possibly be correct for all. It's certainly part of the experience, but not the whole thing. So make sure you go through the different laws of perceptual organization, and they're all here. They're pretty straightforward. Like I said, there's an activity for this in the module, so be sure to do that. I would like to mention that a lot of these principles can be utilized by artists and so forth to create interesting effects, things like that in artwork and painting. Another thing to pay attention to here is this notion of the figure-ground relationship. Yeah, you want to make sure that you study that. And then here's the classic picture, of course. There is a figure, which is something that is really the object, what you tend to focus on in a scene, and then there's the background. And you can look at this and say to yourself, well, what do you see? It's reversible because you can shift your attention. It could be a vase, or it can be two people, right? And it depends on what you're focusing your attention on. You can see the figure is more thing-like, it's more memorable. It's usually looked the figure is usually considered to be in the front, something closer. Ground tends to be more uniform. Okay, things like that. And this is the classic example there. Once again, our mind is establishing the figure-ground relationship. Another theme that I mentioned in the beginning here, regularities. Our visual system learns as we go through life. And by learning, I mean not book learning, memorizing stuff or reading about things or reading comprehension or anything like that. I'm talking about just the act of experiencing the environment, the senses, the continual bombardment of the senses, the particular stimuli in the environment. And we find regularities, regularly occurring physical properties of the world around us. And you can see there's the oblique effect, uniform connectedness. This is interesting. People tend to perceive horizontal and vertical orientations more easily than maybe something more at a 45-degree angle. That's shown in this picture here, right? Just to give some ideas, with nature and whatnot, that there's enough of horizontal and vertical orientations around us, and also, of course, in our architecture. I mean, look at going back. Go back up here again to the building. I mean, here you can see that once again. Kind of zoom in there a little bit. Look, everything is, there's a lot of vertical, a lot of horizontal orientations all over the place. We tend to build things that way. So our visual system has learned this, and so we tend to be these are a bit more easily perceptive to us, which is interesting. Back down here again. So that's so these physical regularities are important, all right? We have homogeneous colors, and nearby objects have, we look at certain types of color patterns, excuse me. Light tends to come from above. That's another thing because of sunlight and also artificial light. So these are just different things that our visual system seems to be tuned into, various physical regularities in the environment. And this because there's regularities in the environment, it tends to sort of produce a schema for things for us, a cognitive knowledge base about how we generally experience in the world. And Palmer did this experiment some time ago. This was a cognitive psychologist. If something, we tend to more readily identify things that are consistent with that particular setting. Okay, at least that's what he found. Although, interestingly enough, we also have evidence that sometimes things that don't belong in a scene can also be striking to an individual. But he found evidence that, like you can see here, observers, just to go through the method, observers saw a context scene flash briefly. So he's cueing them on a context. It could be like a kitchen, it could be a dining room or whatever. In this case, it's more like a kitchen area. You flash that kind of cues the person. It's setting them up to maybe be thinking about, let's say, kitchens, and then you show a target picture. Targets congruent with the context were identified most of the time, 80%. If they are not congruent, it was only 40%. And this gives you an idea what he did. So this was all the way back in 1975. So you can see the scene on the left is presented first. So this looks like a kitchen with what you might expect to find in a kitchen, right? Cutting board, knife, toaster, utensils, whatnot. Then they had to identify the objects on the right. Okay, that's what they're seeing here. Targets that were congruent with the context were identified 80% of the time. If they were not, it was 40% of the time. All right, so it's kind of interesting. So you prime them for a kitchen, they're going to tend to notice kitchen items. So that's, once again, all this is in your book, of course. You can make sure you study it. What about some of the physiological activity? One of the things that it's sort of interesting. Some of this material is going to connect with the next chapter on attention. What is the physiological basis for some of these perceptual, object perception perspectives? Well, one process, that was studied by Tong back in 1998 was binocular rivalry. Okay, and this is where you can present essentially dual images to people. using special eyeglasses. And that's what's shown here. You have, it's almost like they almost look like 3D glasses, but what's happening is that you're presenting an image where one eye gets one particular image and then the other eye gets a separate image. Now the images are superimposed and in front of the person. But you see how the red is going to get sent here being processed by the right hemisphere, and the green is going to get processed by the left hemisphere due to these special glasses. So essentially, one uh, one side of the brain is getting one image which rivals with the other side of the brain. That's why they call it binocular rivalry, which is sort of interesting. And you can see the explanation here. This is all in your book. Um, you can see here, looks like a house versus a face, all right? And you can see because of binocular rivalry, that's because you have two images on each, one on each eye, they're rivaling each other. The observer's perception alternated back and forth between the face that you can see there and the house. Okay, what's interesting here is whether or not they're perceiving the face or the house, you get differential activity in the brain. Okay, so when the observers perceived the house, activity occurred in the parahippocampal place area, which I'll mention here in a second. And that's shown in the left. Okay, that's the red areas. When the observers perceived the face, activity occurred in the fusiform area, and that's the green right there. So what's interesting here is, and I'm kind of jumping ahead to the attention, if you have subjects focus on the house versus the face, you get different activation. So the subject's attention it's literally like a mind over matter. The subject's attention can affect whether or not one part of the brain is active versus another part of the brain, which is very interesting. So changes in perception and changes in brain activity mirrored each other. That's what they found. So they found a correlation between a particular perception, whether or not it's a face or a house, and activities in specific parts of the brain. That's and then once again they go into make sure you look over some of these studies here. Make sure you spend some time doing that. Okay, so this leads me now to the faces, right? Our face is special. This is an important part of the text. Make sure you go through this. I know I have an activity for you in there as well about this. Fusiform face area. This is a part of the brain that responds only to faces, right? So this is an area of the brain that it's located, it's sort of wrapped in the human. It's kind of it's sort of it's where the temporal lobe is, and it kind of wraps under a little bit. And when humans are shown images of faces, this area will light up. It will show more activity. And that's very important for face recognition. All right, face recognition. However, there are a lot of other places in the brain that are active when you look at a face. A face is a very, very important stimulus for us. And you can imagine why. If you have prosopagnosia, where you have an inability to recognize faces, this is a serious problem. It's a problem for communication. And people that have this can show some great distress because you can't even recognize sometimes you can't even recognize yourself in the mirror, which is obviously would be disturbing. But here you can see some other areas involved. You got the amygdala, superior temporal sulcus, and the frontal cortex. All of these varied areas are each involved with particular aspects of the perception of faces. Amygdala is activated by emotional aspects of faces. The STS here, looks at movements of the face, things like that, mouth movements, and the evaluation of facial attractiveness, which is something that is important for humans. We spend a lot of time looking at each other's face. All right, that's why it's always been advantageous for a person to have a nice looking face, because we have cortical areas that are particularly activated and we respond to that. And so that's important. And while I'm thinking about this, I was looking at the amygdala. This is a fascinating area of the brain, and here's a picture that shows you all of this. There's the frontal cortex. The amygdala, when they do the dotted lines, it means you can't. The temporal lobe here is covering it. It's deeper. The amygdala is subcortical. The fusiform gyrus is right around here. This is the face area. It kind of wraps under. The superior temporal sulcus is also under here. The occipital lobe, they're just talking about there. That's the visual cortex and associated visual areas. So all of these things are going to be active when you're looking at a face, and other things too. But there's a particular pattern that's important here. So all of these areas are working together to evaluate the attractiveness of the face. Are you afraid? Is this person's, are they scaring you? Are they being aggressive? And so forth. Um, and here you can see another thing that's interesting with faces. I wanted to mention this because the eyes are so important. All right. When you get rid of the eyes, it's hard when it's harder to perceive the eyes of a face. And this is a fellow named Newt Gingrich. He's a politician that I guess I'm not sure how famous he really is, but they used him anyway. When you make the eyes more salient, it becomes much easier to remember who it is. You get rid of the eyes like that, it becomes very difficult. Okay, that's one of the reasons why you put sunglasses on somebody and it's harder to know who they are right away, even when you can see the rest. I'm not saying it's impossible, but it makes it a little bit more difficult. All right, so this part of the face is important. So once again, I'm mentioning this because it's an interesting question about faces. How do we perceive that face? Is it just the sum of these individual parts, or is it more of a holistic? And you'll see in the text that there's evidence for both a holistic and more of a segregated approach to face perception. But going back to this, what I wanted to share with you is an article that I found relating the amygdala, and the amygdala, and of course these parts of face perception to social issues. And here I found this. This is interesting. I wanted to share this with you because neuroscience, studies of visual perception and the sensory and perceptual system have become much, much more interdisciplinary. So here you see a journal of social cognition or social cognitive and affective, meaning emotions. This is an area where we're actually combining, your neuroscience with more of a social psychology type issue. In this case, you can see here this is an interesting. I just wanted to share this with you. I just once again I just did a search, and you can see this: the effect of skin tone on race-related amygdala activity. All right, so this is a study where the investigators wanted to see if skin tone, if you got a group of people, and when they're perceiving the faces, looking at face perception, was there an associated emotional response looking at different skin tones? In other words, they're looking essentially at maybe a biological correlation in the brain to maybe a fear that could be the foundation for things like stereotyping and racism. So here's an interesting area of research where social psych merges with sensory systems, perceptual studies, and so forth. So you can see here, this is very interesting. What they found was that when they got these subjects, let me just read this to you a little bit. Previous work has shown differential amygdala response to African American faces by Caucasian individuals. Furthermore, behavioral studies have demonstrated the existence of skin tone bias. So once again, this is all much more like a social psychology course here a little bit. The skin tone bias, the tendency to prefer light skin to dark skin. In the present study, we used fMRI to investigate whether skin tone bias moderates differential race-related amygdala activity. In other words, I want to show pictures of people with different skin tones and see does the amygdala activity change when someone's looking at these things. They chose 11 white participants. They viewed photographs of unfamiliar black and white faces with varied skin tones. They found greater amygdala activity when black faces were presented than when white faces were presented. Furthermore, dark-skinned targets elicited more amygdala activity than light-skinned targets. However, these results were qualified by a significant interaction between race and skin tone, such that amygdala activity was observed at equivalent levels for light and dark-skinned black targets, but dark-skinned white targets elicited greater amygdala activity than white-skinned targets. So the point here is that they're trying to show that there might be that the amygdala, just to make sure I understand this, the amygdala is a part of the brain that tends to be involved with the learning of fear, amongst other things. It's involved with emotional responses. It's a very important part of the brain because often emotions, if something is emotional or an event if it elicits an emotional response in you, you're going to remember that far more than you are just kind of, Emotions are an easy way to remember things. If an event has a strong emotional significance, you're much more likely to remember it than something that has very little emotional experience. So anyhow, they're just, they kind of go through. Now, I'm not. This is obviously not going to be under test or anything like that, but it's just an interesting paper. I thought I'd share it with you, and it's not perfect. There's problems with this. They only have 11 participants, although in an MRI study that makes sense. They're all volunteers, which is interesting. Um, and it looks like they're all males, which is a problem, I think. And so forth. So maybe a different sample would be nice, but you can see some examples of the stimuli, right? So they're just showing people with different skin tones and stuff like that, and that's what they found. So it's very interesting. So and then they're showing you here there's a little activity in the amygdala. That's an MRI image, fMRI image, and they're showing that the amygdala is a very small part of the brain, and it has different parts to it. So I'm being kind of general here. But I thought this would be interesting to share with you. So we have this merging of neuroscience with perceptual studies, perceptual science, and also with more of a social psychology application. So I thought that was very interesting. Okay, we get back in, and that is basically what I wanted to go through, just to give you some ideas of what to sort of focus in on. Um, As always, if you have any questions, be sure to contact your instructor, and you have a great rest of your day.